Yeah, thanks. So my name is Philip Vernon, and thanks, Ellen and David, for letting me come in here and talk to you guys. And my background is actually in architecture and digital fabrication, so more making things basically. And I've spent the last 10 years or so in Shanghai in China doing some of that with a lot of composite kind of materials. And today what I wanted to focus on was really the surface. So I titled this talk Digital Skins, because I think more and more we're wanting and able to have kind of control over the surfaces and the touch and feel of the kind of things that we make. And so I'm just going to go through some work and then hopefully also ask you guys some questions as well to have a sense of where you guys are coming from, and hopefully between two of those things it'll be interesting. So the way I'm gonna kind of structure this is starting off with this comparison between two opera houses built in China. Both of them were by the Iraqi-born British architect Zaha Hadid. So maybe before I go further, what's most of your backgrounds? Like engineering, audio, visual, faking it? What's the, it's some combination.
I'm a designer, planning,
Yeah.
and GIS.
Oh, cool. Any other volunteers?
Just audio, sound design.
Yeah.
Just engineering.
Engineering,
Engineering.
all of it.
All of it.
Good.
All of
I
it.
wish.
Excellent. Yeah, cool. Anyway, so
I have architecture background.
yeah, that I know. That's probably why I get to show you this stuff here. But yeah, so
Yes.
these are two two opera houses. The one is in Guangzhou and was built in 2008, and it was sort of her, in China at least, breakout work, let's say. And then this second one, Changsha Meishu, who is the Westlake Cultural District, also in China, in Changsha, and it was finished around 2018. So the company I was working for in China built both of these two things, and they provide a good sort of reference point of kind of the state of the art of building these kind of spaces. And I think maybe the digital culture that's kind of shifting over time. So just really briefly, you can see this one to the left. Obviously the geometry is complex for both of them, but this is sort of high gloss, metallic, smooth, shiny. It's kind of the type of surface that you would have seen coming out of maybe Maya or Blender or something like that in the decades before, right? And this, on the right, you don't see in so much detail, but you can see the geometry has gotten more complex. The lighting is integrated. It's not just sort of simple can lighting that's been arrayed over the surface, but it's actually integrated and it's matte. And you'll see later that it's actually artistically painted wood finish, right? So you're kind of just like, when you go home to your BMW, right now, you're seeing those coated with like a matte finish, or you're seeing, I don't know, for example, like rusticated wood or these kind of things, like you can see in Zaha Hadid's work, but I think in sort of digital culture in general, this sort of desire to move from something that's kind of very smooth to something that's a bit rougher and more natural. And so that's sort of a bookend across the 2 decades. So here is that same image a little bit closer up. And then I'll go into a little bit of how this was made. So on the top left here, you'll see this 3D model, right? And so this is coming out of basically a NURBS software package. So NURBS, I don't know how many of you guys know what that is, or like Rhino, for example, yeah. So it comes out of basically car design in the 60s, right? So it's non-uniform rational Bezier splines, which basically means Right, well, basically it means that sort of like if you're using Illustrator in graphics, it's a vector graphics, right? So it's mathematically defined and you can scale it without losing resolution versus like Photoshop and raster-based images, right? So this is basically the same concept, that it's weighted points and it defines a mathematical surface. And so, you push and pull it around and you get this. The thing that this led to was, no two pieces from this surface are going to be exactly the same. And so when Zaha proposed this, my boss, Jerry Koo, from Taiwan, basically built a lot of your sort of typical opera houses, much more standard uniform moldings where you use the mold many, many times. And he basically was thinking, like, how do you actually build this, right? Because if you make a mold, make a piece, and then throw the mold out, basically you've built the entire thing in reverse and then thrown it away, which from cost and environmental perspective is just kind of crazy. So he came up with this very old but new application of using blocks of wax to basically cut the shape, make the unique pieces, and then afterwards melt down the wax and just keep using it. So we'll take a look at a sort of life cycle analysis of that a little later, but just intuitively you can tell that it's way simpler and way more effective than wood or foam or something else that's gonna have to be thrown away. So the next thing you'll see down here, image number 3, is basically chopping those surfaces into unique panels, right? So based on the size of your wax, you chop it into a piece that can be molded from it. And contrary to what you might expect for something with this kind of complex geometry, the simplest way is actually just to project an XYZ grid, because then you can move the pieces into place and survey it really easily. So that's what you see in this image here, that pretty much wherever possible, it's just horizontals and verticals. And then where the panel depth gets beyond what you could mold from that wax, then it will get chopped in half, for example. So you can see that's what's going on here to the left. When you look at the actual surface of it, that at this sort of like bullnose detail or some of the others, the panel sizes get much smaller because otherwise they would like exceed the bounding box of the wax, right? So basically it's taking something that's kind of complicated and making it as simple as possible, which for all forms of engineering and even art, right, that's the real goal. Like overcomplication might publish a couple of papers, but it doesn't like get you to something truly valuable a lot of times. So there you have it, and you can see on this complex surface that there's this texture on it, right? And so that's for acoustic reasons to basically, I suppose it'd be refract the sound, or at least like change the way the sound is hitting the very hard and dense surface of these gypsum panels. So you can see that. And maybe one other note before I move on, in the geometry, you could speak to this better than I could, David, but most of your concert halls and auditoriums around the world kind of fall into two types, either the shoebox or a sort of amphitheater type space, right? And that's basically because acoustics is very difficult to predict. You can kind of model things, but you really never know what's going to happen. And there's so many stories of like, after they installed the organ, it suddenly became perfect, or they put up curtains and fucked the whole thing, or, it's very difficult. So this geometry was actually somewhat cutting edge, or at least trying to manage it was somewhat cutting edge by this New Zealand acoustician, Howard Marshall. So he won some prizes, and he had the unenviable job of trying to wrangle this thing from, you know, this sort of wild design into something that you could predict and would be worth having as an actual opera house, so. Yeah, so this maybe is similar to what some of you guys are doing, but once you've got your individual panels, then you'll bring it into a CAD CAM program and just set a tool path, and you'll see there on the top left, it's just a 3-axis CNC machine, which is cutting out the shape and the path that you set in the software. So I'm curious, do you guys do much work fabricating with this kind of stuff here, like CNC machines or?
We have some good labs out in CLC here in
Yeah.
this building, we have CNC here.
Yeah.
Just laser cutters. 3D printer.
Yeah, I mean, any thoughts on as to the reason to use this kind of machine rather than, let's say, 7-axis or 5-axis robots?
The material you're needing at the end with the gypsum is a lot easier to move into this, but you can do the liquid form.
Right.
The CNC, any removal process or every process will give you that texture.
Right.
You know, and it's
Yeah, right, I think that's definitely part of it. I mean, the wax, one of its good points in this is it's pretty easy to smooth out the lines that are left by the tool, or the tool path it's called. And then another thing is if you do any moldings or castings, right, the thing that you're always worried about and always trying to avoid is undercuts, right? So if you have a geometry that's like this and you're molding it, your piece can come straight out. Versus if it's undercut, let's say like this, it's gonna lock into the piece, right? So then you're either breaking out the mold or manhandling the piece to try to get it out of there. And using a 3-axis machine, you know, not only is it cheaper than having a whole series of robots, but it's also, you know, by definition that it can only cut something that's XYZ vertical. So there's always, so if you can cut this, you know for sure that you're going to be able to demold it one way or another. And so Ebro, the company that I was working with, at the time we had 20 of these big CNC machines, just to be able to make the kind of volume, meet the schedules that you need for these complicated pieces. So actually, if any of you guys are roboticists by any chance, one of the thoughts I've had is, you know, rather than having 20 machines with one individual spindle, you could, you know, pretty easily, and the machines are probably about the size of this table, a little smaller, something like that. You know, you could pretty easily put a couple of spindles on that same gantry, and then instead of having a huge factory with 20 machines, you could have 4 or 5 and like basically put them all in this room and have the same output at 4 or 5 times the speed to do that. But apparently that hasn't been done to my knowledge yet. Anyway, so that's the wax and the machining, and then here you see the layup of the parts. So yeah, this is just glass fiber reinforced gypsum, and so just gypsum plaster, which you all know from be it art or be it drywall or the art of drywall. It's basically the same thing, higher density so that it binds well with the glass fibers. And then the glass fibers, just like with reinforced concrete, that's helping you in tension. And then the gypsum is more for compression. And so you see that with a couple of steel embeds to connect back to the structure. So the same concept works for a lot of different materials. This, you lay it by hand. You can do the same thing with concrete. That's generally sprayed GFRC, so you'll have a hopper gun and fibers, and you'll spray that together so you get a sort of non-uniform random alignment of these fibers, or then same with like fiberglass, plastic type stuff. You either spray it or hand lay it up and roll it and compact it. So that's what these ladies are doing here. And then here's the result, that you get your piece. It's got, if you see here, it's got sort of a recess, and that's because just like drywall, the way that you get to these seamless finishes is you tape the joints, mud it over and sand it until it's smooth. So it's really similar to, you know, things that we're very familiar with, but just controlling the geometry in a different way. And again, it's all pretty much smooth. So you can see that acoustic texturing there along the sides and the lights overhead. And so this was done in 2010, I think was the grand opening. And the construction of this, from getting the 3D model to painting it on site, was like 4.5 months. So relatively quick in a lot of ways. So here's another looking the opposite direction. And actually, you know, you would hope that all of these lights were done in like a BIM model, right? Building information model. In fact, they were done by hand with like a large circular drill after the fact, which is clearly not the ideal. But that's why this sort of starry night is perhaps hazier than, you know, you might have originally intended. But that's life, and that's probably why the next one went so crazy with controlling the lights. Yeah, so here's just a basic kind of life cycle analysis. Let's see, I think we know who can see this recording. And so this was just compared to sort of typical practice, which if it was a simple shape, you would just bend wood, if it was single curved, or then foam. For something that's double curved, then you need to carve out the shape. So we picked polyurethane foam, and total environmental impact, I'm sure you can argue about how one measures that. But in terms of the waste footprint, it's very clear that there's much less waste. And then associated with that is much less carbons. And the Ebro, the company that I was working with doing this stuff, they were using the same blocks of wax for something like 10, 15 years. Like they're still doing it today. And so, you know, so the more you use it, the lower the overall impact is for these molds, right? And yeah.
Just a pandemic candle maker in training, but there's different kinds of wax. There's like soy, there's
Right.
Does that make a difference, or?
I'm sure it does. I think that this is like a paraffin type based wax, but I couldn't tell you the exact chemical composition, but for sure it does make a difference. Yeah. And let's see. And so here we go to the next. I mean, this is fairly intuitive, but just the various numbers associated with these things, right? Where you've got potentially a foam mold, you mill it out, that takes energy, and then you pneumatically just blow out all of the dust, basically, which is hard to collect. And then once you've used it, pretty much everything goes to the landfill. And like simple geometry, you know, maybe you'll use it hundreds of times, right? But for complicated geometry, you don't have that choice. So the wax is different in that basically, you know, you have your wax, which is petroleum based, so it's not like a perfect situation either. But once you have it, you can keep using it, and basically, even in the cavity that's cut out with this mold, just pour back in the melted wax and do it again. So it's really only this full melting and reformation of the wax block was like maybe once every couple of months that you would just want to start fresh with a new block of wax. But you could do this in-house with this big sort of hot tub type thing that was around maybe 70 degrees centigrade. So what's that, probably
So there's a text, I think Michael said this is missing the raw material acquisition impacts for the wax.
Yeah, very true, yeah. Yeah, and yeah, so that's something that actually I'm hoping to work with the wax supplier. Because when we did this life cycle analysis, basically things were already up and running. And now I'm working with the same supplier to sort of tweak the formulation so you can cast other materials. And I hope that being directly involved in that can measure this. Because it's true, otherwise, if you're just starting with this as zero, that it's not a great comparison. So yeah, so here's another just batch of different buildings that we had the chance to make with this process. And again, you can see that, you know, they're coming from different people, but there's a similar spirit of they're pretty much all, you know, if not high gloss, smooth and maybe satin or semi-gloss, because just like with your car or with whatever, the glossier the surface gets, the easier it is to see the imperfections. So if you don't want your painters to be, you know, on the job site for months and months, you have to, it's wise to do something not as high gloss. But yeah, so this was basically a little coffee house in a big mall in Shenzhen or Bangkok. This one is by some Chinese designers, WAA, for this Inchuan Art Museum. This one is coming from the Los Angeles-based Morphosis Architects. And so we've got some basic shapes and then this kind of higher gloss sculpture here. And then this is for this jewelry brand, I Do. A big one in China. I saw one here that's We Do, even more. Anyway, yeah, but this was, yeah, it's a big brand, and they worked with the architects Anti-Statics, who are based out of Beijing and Ithaca, New York, and Yue Minjun, who's one of the big pop artists in China, basically. So anyway, and lots more pictures similar to this, but this was basically the kind of stuff that I was getting the chance to work on over these past few years. And so the next question, or the next topic, right? So here this is, we talked about this already. Here's the architect finding inspiration, perhaps not, but anyway. And so this is basically more of the same, but 10 years later, right? So 3D scans of the building to make sure that there are no clashes with this geometry. You can see the wax is that much more complicated. And then this down here is the GFRG gypsum panels, and all these sort of polka dots are for 3D scanning, right? To basically to show the client that, you know, even though you might be tempted to just hire plasterers to do this by hand, which sometimes happens in China, and sometimes also happens in Italy, where there's like, you know, the desire for tradition and cheapness to coincide, perhaps. But anyway, so that's that, and then there's the final image there. And so here's kind of the point that I was trying to make was that they actually, Zaha Hadid Architects, wanted this to all be made out of wood, like steam bent wood or something, but A, that would be very difficult, and B, it turned out that the fire code would not allow you to have a gigantic opera house, you know, totally clad in bent wood. So the result was this more naturalistic kind of, you know, rougher matte type of finish. And I think that this is kind of where things are going, and also that there's a lot of interesting technology that can help you do this. So here's another sort of similar comparison. Furniture, same architect, high gloss, car paint, and then over here, very similar form, but it's like a rough plaster cast in like, almost like gunny sack type material, so that it's very rough and there's a difference in texture and color and finish, basically. And so this is much more recent by, they're based out of Bahrain, actually, and control. So here's the kind of stuff that's, I think, we're gonna see a lot more in getting these kind of naturalistic finishes. So I don't know if you guys get to play around with this very much, but this is basically printing that's actually got texture, right? So it's used for art reproductions, and so you'll digitally scan a photo or a material or whatever at something like 1400 DPI or so, and then you can actually print at that same level. So here it is with the color and the texture, and then here it is just the texture. So you print layer on layer of, be it white ink or really it could be any kind of jettable resin, essentially. And so the level of resolution that you're able to get is pretty amazing. And thinking about this as a mold, I think it's gonna happen more and more often. So here you can see how it's made, and it's not too dissimilar from kind of the GIS maps where you get a height map, right? So you're using a 0 to black range to define the 0 to 100 height, right? So there's the height map image, and then this is in like a ZBrush, for example, or Blender, or one of these kind of digital sculpting tools, where you'll take this alpha map, it's called, and apply it to the geometry, right? And so you can kind of stamp, just like you would with a sponge as a kid, or you know, stamped concrete pavers or whatever, you're basically doing the same kind of digital applique, but at very high resolution, right? So we're moving from that sort of like vector-based NURBS where it's all math and surfaces to something that's a much more kind of mesh or pixel type based thing. So here, same thing, and now there are more and more tools which I kind of hate to define them as AI, but basically you can interpolate these images into a range of different outputs. So here it's a normal map, right? Basically showing when light hits this surface, where is it gonna bounce to? And so that's useful in renderings because you can basically prescribe how light is gonna scatter. So I had the chance to just print out this same height map on one of these graphic printers. And so you can see the buildup of the ink there. And then you can see we printed it on this flexible substrate and then cast it out of ultra high performance concrete. And basically, you know, you can get some pretty air bubbles and problems aside, you can get some pretty high resolution moldings. And the fact that you can do it on a flexible substrate makes a big difference, because then you can basically print a skin, manipulate it, and get some sort of geometry, right? So you're really just controlling a very, very thin cross section at a high resolution, and then after that, the shape is pretty general and generic. That's the idea in any case. So here's another kind of gypsum casting using the same thing. And because the ink was made for art reproductions, it was totally destroyed, I have to say. Like, it's not meant for you to cast concrete. Like if we were to cast concrete on one of these fine images here, the results would be tragic, of course. So we had to basically do an intermediate of silicone in this case. But there are more and more people that are jetting sort of flexible resins at this kind of resolution, right? So anyway, this was with a, very good artist here. And then I'm gonna show some images of how this might apply, right? So here's sort of a traditional ink rubbing, right? From this huge cauldron or ding And basically you see the same exact principles at play, right? That there's this sort of real beauty to taking the texture and to unwrapping a surface and then turning it into, you know, a flat kind of projection of this artifact, right? And so this is, you know, the tradition of doing this kind of representation or copy exists for a long time in China, but you can do more of this kind of stuff digitally as well, which is where I think this is interesting. So here's the Mongol thing itself with all those characters on the inside, right? And then you see something very similar. So here's the square cauldron. This is from, I think, the Zhou dynasty. And you see a similar rubbing where it's this unfolded elevation, right? So you're describing in 2 dimensions a 3-dimensional object, right? And so there's, as you can imagine, there's tons of history and math and beauty behind this kind of stuff. Here, for example, is Buckminster Fuller's Dymaxion globe, right? And so it's the same thing. And this is his, well, he got obsessed with geodesics firstly, but secondly, you know, because of the way that it's sort of a multi-piece puzzle, one of the things that was, it's basically a new way to reframe looking at the world, and you can sort of unfold it in a variety of ways. And in the 70s, when this came out, it was also sort of appended to a political discussion about maps, and like, I'm sure we all know that, you know, maps distort things inevitably, and normally we distort them to favor ourselves if we can. So but it's the same principles at work, right? That you've got a topography, you've got a flat unrolled surface, and you could put this back together into a 3-dimensional shape to make something. And so let's see, next image. So here's how that works in basically computer game design. And so I've been trying to push some of this stuff closer to computer game design and kind of theme parks in a way, because I think that these days we have such amazing models, you know, with millions and millions of polygons that are used to make movies or games or whatever. But when it comes to the actual construction of these kind of spaces, it ends up being made very, very differently, as you can perhaps imagine. So anyway, how things are working in movies and games is that, you know, you'll sculpt using digitally, and then here on the top right, you've got the UV maps of the surface, right? And so you'll try to, just like a globe, you're going to try to split it up in a way that has the least distortion, or distortion in the places you care the least. And then you'll unwrap those UV maps to flat and export that for texturing and painting and finishing in programs more like Photoshop, or some that can apply, again, those like height map stamps to the thing. And then you'll suck it right back onto the 3D model, and you've got, you know, hopefully what you wanted, right? So as it might be fairly clear, like, you know, with the technology that's coming out, you could do the same thing, and then you could be printing this stuff. And as long as you have an understanding of how much deformation there is and how you've seen it back together, you know, you could get something at 1,400 DPI or whatever the, you know, some Swiss printers were bragging of even more, but an incredible amount of resolution, right? And you're really just paying for, instead of, let's say, 3D printing this gigantic rock at that kind of resolution, you're doing it just at the level of the skin, and the rest is sort of roughing it out, right? So that's kind of the direction. I've got a couple prints I'll try and show you guys here too. And this is sort of a related tangent, is that just like we were talking about interpolating these textures and you know, using kind of algorithmic or, you know, AI kind of ways to do this. So this is from, you know, maybe 80 to 100 years ago, the surrealist Max Ernst, right? And so I throw him into the mix just because I think a lot of the conversations about like automatic writing and sort of hallucinatory methods of imaging or trying to find something that you wouldn't typically find using a system was, you know, very much in the language of, you know, collage or surrealism or all these kind of things. And so it's kind of a pity to see so many kind of venture capitalists talking in a very obscure way about these tools when actually there's a ton of history and there's a ton of things that you can really bring to bear to talk about it in an intelligent way. And obviously things have changed since the Dadaists or whatever, but for example, it's very similar in some ways. So he says, beginning with a memory of childhood, in the course of which a panel of false mahogany situated in front of my bed it played the role of optical provocateur. I made from the boards a series of drawings by placing on them at random sheets of paper, which I undertook to rub with black lead. So this is maybe the most architectural kind of one of it, where you see just printing the thing itself. But of course, then it tries to go into the subconscious, which, you know, here's a bird. So the author of this work, this procedure is revealed by following the real equivalent of that which is already known by the term automatic writing. So by widening in this way the active part of the mind's hallucinatory faculties, I came to assist as spectator at the birth of all of my works. So I'm not well read enough to talk to you about authorship in the digital age or anything like this, but just to say that, like, you know, we're looking at very similar problems in a certain way that you can interpolate and take and combine in interesting ways these data sets, be it from the physical world into an object like this or other ways. So this is just a simple interpolation of those, he called it frottage, so which is just rubbing. And so there's a normal map generated from that image, just, you know, with a basic filter, and then here's more of the same. And that's pretty much it. So I do have a couple of things that I've actually printed. These were not printed with the Swiss, regrettably, so the resolution is more urbane, but here, for example, here we just 3D scanned a couple levels of grit of sandpaper. And this is purple for the same reason that that's purple, I think, that they just printed the normal map, right? And so purple basically means it's pointed straight at you. And then as you go one way or the other, it's going to become red or green or blue. So you're using an RGB space to define an XYZ kind of coordinate system. So I don't know, you can, it's not super fragile. You're welcome to play around with it. And then this is a similar kind of use of the technology, basically where, again, coming from a sort of digitally sculpted model, you can do all kinds of things. But then the gap that I see is that you don't always know what resolution the 3D printer is going to spit out. I'm sure you've seen ones that look like toothpaste, you know, and then you've seen other ones that are pretty good, pretty amazing. And so this was basically an attempt to do the same, to make a color swatch, but actually a texture swatch. So rather than saying, you know, this is the kind of blue that I want in this room, and picking your color, sending it to, you know, a factory or Home Depot or whatever, and they mix the same thing for you and send it back. The idea is that basically, you know, we can scan and define the level of textures that these machines are able to print. And by doing so, you can define that haptically, let's say. And so then you could be, you know, the guy or gal or nerd or whoever is at their computer sculpting this thing, and the people who are in the factory who are obviously coming at this problem from a very different direction. You have a set of understood references, and so whoever's designing the thing can specify the level of texture that's going to be printed. and know that it's gonna be within certain tolerances, so. I've said enough about that, you can just, you know, touch and believe perhaps, or not, but, yeah, I think that's about all I've got, but, yeah, be happy to, you know, if you have questions or concerns or whatever, if not, I'll ask you guys, so.
Well, you kind of just, at the beginning, there was the amphitheaters, which were really beautiful, and I'd love to see those in person.
Right,
The picture was amazing, but just probably being there, but just, you mentioned the amphitheater, which was like, you know, ancient Greece technology to amplify
right,
modern, we have, you know, amplification, so to turn out actually the traditional Jewish synagogue shoebox is the best place to experience music.
right,
And so all these, like, we have to do an amphitheater and you can't, you know, it just sounds bad.
right,
And you said that someone went in and with the sound.
Yeah.
And- But I was wondering about the actual materials, like thinking about the acoustics, like something that bounces, they kind of did that sculpture to help.
right, so what, my experience is, so for the, lower pitches, and I'm not in acoustics, but generally, you want the panels as thick as you can afford to make them for a concert hall, just so that it's gonna reflect the lower register of sound. And so typically, like gypsum is good, it's pretty high density, sometimes you'll see concrete, but it's very, acoustically dense, but also very reflective, so then that becomes your next problem. And from what I've seen, typically you calculate out, you know, what are the soft materials like the chairs and then the presence of an audience. And then beyond breaking up the sound with the texture, what you'll see sometimes is like perforations and such, where behind it you've got sort of acoustical fiberglass that's going to absorb some of that energy while not burning like straw, basically. And so that's
While I was thinking about the sound, I was also thinking
Yeah.
about the reflectivity
right,
of that, especially that Gold Theater was amazing, but I was just imagining something happening on stage, then just like the light
the
bouncing.
light going all over the place.
Like, and you know, breaking the fourth wall is very, you know, Chinese tradition, but that's,
I'm sure very few people have thought about doing it that way, though. Yeah, I mean, I don't know. I'm sure. I doubt that you sit in a space like that and totally lose the fact that you're in a very unique space. I think that's probably why you build it, right? That like the architecture is not trying to disappear in this particular case, right? Like it's gonna be a very particular experience. Was that worth doing? I mean, I'm sure. Yeah, I'm sure there's
I
debate on that.
want to go try it.
Yeah, no, you should. And I'm sure there are good papers on this by the actual researchers who at least push the discipline forward, if not figured out the real thing. Yeah,
Do you know if the audio panels ended up working well?
the audio panels, like
The texture?
the texture. I couldn't say, I guess. I mean, I want to say yes, because it's been there for a decade or whatever, and it's popular and so forth, but I, from an acoustics perspective, I can say. I remember a professor of mine had this great sort of German nerdy acoustics joke, which was that, you know, what's so great about the Royal Albert Hall is that it's the only place where you'll hear an English composer twice because of the reverb, right? So basically, typical German musical put down on the English, but you know.
So in your theme park work, I know there's probably a lot of people you worked with, but did you ever have any connections to Downey Thorpe James here in Boulder who's done?
No,
Okay.
I haven't, I've been, yeah, pretty much in the.
Yeah, the experience that one of the guys I knew who designed some things was that it was in China and it's like, oh, he had to be on site so often because a bunch of material would arrive and they would immediately just say, we've got to put this in, whatever it is. Right. Regardless of whether it was scheduled or not.
Right, I mean, I think like the joy and the pain of working in China was that there was a real urgency to do something new and to really develop the country. Yeah, and so sometimes you would rush very correctly in the right direction, and sometimes you would perhaps be rushing in the wrong direction versus like some of the high performance concrete I worked with. We had the chance to do an early facade in China, and it's like really taken off. And then here in the States, it's like people are just sort of resurfacing a few roads and like filling some cracks with the same material and
I
then.
wasn't sure that there was something the economist said, there was so many units of concrete used in, I don't know, 2010 or something.
Oh,
like
sure,
that.
right.
And there was China and then the rest of the world, and China was 6 and the rest of the world was 1 unit.
I mean,
Concrete.
it was, right, it's an incredible place, and then also an incredible moment, right, where like the country was more or less sort of told to remain rural in a way for a number of decades, and then sort of told to go in the opposite direction in the decades that followed. So just so many millions of people needing to build homes and set things up, it's, yeah, quite incredible. Yeah,
The interfaces on wrapping, the.
Yeah.
Particularly for the 3D model where you're laying it flat for use as,
Yeah.
Photoshop or other painting. One of my friends had been at Meta for 3 or 4 years ago.
right,
But they were using some of the early, design. Their job was actually sculpting.
Right.
Painting.
Yeah.
All within that 3D area to be able to turn the pieces over and zoom them in and get.
yeah, right.
At that point, I wonder, as we evolve in that space, what that will mean for, being able to do that more rapidly or more precisely in the context of where
Right.
the piece will eventually be present.
Yeah, I think that's totally a good observation. So there's, yeah, different elements of that. I think everywhere you pay a price for resolution, and so you're always searching for like the difference that makes the difference in a way, right? And so, yeah, that's different in sculpting a character, like computer games and videos, you're trying to get a lot of information and then bake it down to as little as possible, so you're not overwhelming your GPU basically, versus architecture, and then you're, you know, iterating over time to get your frames and all this, versus like something that's physically constructed. I would want all of that information, but I really only want it once, you know, so these kind of tools that are like physical based rendering algorithms or whatever, they're trying to take something that's a physical model and cram that information into a flat surface that's gonna interact in a naturalistic way with the render, but that's not the same thing as, you know, like this would be difficult to 3D print. Like, it would be a different kind of file format almost, or like just you're moving in a different direction. So, yeah, I think, which hopefully relates to what you were saying.
I just wanna say thank you. I always, changed my perspective on this. I always thought like whenever I buy furniture, it's always the cheap stuff that's particle board with a oak veneer.
Right, right.
Cause I just can't afford oak or something, and then
Yeah, yeah.
this actually makes me feel better about everything, cause sometimes materials make more sense.
Right.
And then the Max Ernst quote, like, this is cool, cause sometimes, yeah, you want the natural feel, but sometimes materials, especially on large scale.
Right,
And, you know, match, you know, you mentioned fire code, sometimes it makes more sense to have best of both. Do we have a 3D printer or 3D?
So-
That could do this?
this
anywhere?
would,
Yeah, we could do a resolution 3D print like this, so. Like the one with the,
Yeah.
on
I
China,
have that, I have resolution real quick. I mean, we've got just
3D printers.
cruises.
I mean, this is actually done on a graphics printer, not a 3D printer. So this is like a flatbed,
Okay.
and it's lower resolution. I got it done on like a fast science, and they printed it on an Osei, Arizona, or like a Muto. It's the same thing they'll do to like print braille on like an acrylic sign for the washroom or whatever. Yeah, and then the ones that are better are the like art reproduction prints, and they're around, but I don't know, they're expensive, but people do this now for material swatches. So like with this thing, similar to what I'm doing, but they'll like scan loads and loads of brick, print the veneer on something like this, and then they'll hand you like a notebook. instead of, you know, the sort of death of a salesman, you know, bringing in just bags and bags of brick, and the architect's always gonna be like, well, do you have one that's a little more brown, you know? It's always that, so, yeah,
There's a phase change one where it's the hot water.
I mean, that would be,
Possible.
that would be so cool, right? And I think it's totally doable, it's just, I don't know that it's been done in that way so far.
Yeah, have you played with like a UV resin 3D printer to do something similar to this?
So what?
Have you played with like a UV resin 3D printer? To do
I haven't so far, I would love to, I've talked to, like, I've seen some people that are kind of doing this for, like laminate flooring. So they print sort of like a height map of flexible resin, and then it's put on a drum and just, and it's replacing that drum used to be a gigantic steel thing that was put on a lathe for, you know, God knows how long, right? And so so the texture is small and the like bending radius is, you know, it's not like spandex or anything, but you can do some real curvature. So, but I think it'd be a lot of fun to explore that type of thing for many applications.
We did some work with, some of the blind school in New Zealand. And
Oh, yeah.
we're trying to translate data into something that they can see.
Right,
One of the simplest ones was wind speeds in a hurricane.
sure,
Able to
right,
see where the hole is.
Right.
Also, printing, 3D maps of like their area of New Zealand, so they
Yeah.
in this region, they
Oh,
know
that'd
where
be
the
great.
mountains are and the craters.
right,
And be able to show the moon, how
Right.
big the moon is in relation to the earth, so that they can get that sense of awe of.
Sure.
oh, How small we are.
yeah, right, scale that's not visual.
Yeah, it's not always texture, having texture convey more than just the. Yeah.
Totally, there's a quote by, I think it's like, Dura, who I don't know who he did, but like love lies in the sense of touch, right, which is a wonderful kind of haptic quote, and yeah, I think it would be so fun to print these out, like just first to have a black and white, then to have the white on white raised texture like that you could touch and feel. And then I don't think there's like structural reflective inks that you can really get your hands on at this point, but to have this printed as like a metallic would be amazing. And then you could have all your wacky surrealist text as like Braille with an overprint, right? And just like go nuts on some old school etchings. I think would be a lot of fun. Anyway. That perhaps didn't need to be shared, but I'd like it.